How exactly did a novel coronavirus completely reshape our entire world in just 5 short years? I mean, really think about it. We're now in 2026, and the way we work, the way we travel, and the very systems designed to keep us safe, they've all been fundamentally altered. Today, we're going to unpack that massive global shift from 2019 to where we stand right now.
Welcome to The Explainer. I'm so glad you're here. Today, we are going to visualize an incredible journey using data straight from the CDC, the World Health Organization's 2026 Global Assessment, and the latest RVMC implementation reports. By looking strictly at the evidence, we're going to connect the dots of the past half-decade. We really need to understand exactly how a novel coronavirus changed our world and, honestly, what it means for our future.
Okay, let's dive right into this. Here's our roadmap for today. We'll start with 1. The outbreak begins. Then 2. The global response. 3. The current reality in 2026. 4. Lasting health and society impacts. And finally 5. Preparing for the next threat.
Section 1. The outbreak begins. A novel threat emerges.
Let's rewind for a second. In December 2019, a cluster of atypical pneumonia cases was detected in Wuhan, China. By January 2020, scientists had identified a novel coronavirus, shared its genetic sequence globally, and the first U.S. case was confirmed. The sheer speed of this pathogen was just breathtaking. By March 2020, with over 118,000 cases across 114 countries, the WHO officially declared COVID-19 a pandemic. In just a few short months, a localized cluster morphed into a crisis that literally ground the entire planet to a halt.
And the shock wasn't just medical. It was instantly economic. 14.7%. Let that number sink in. That was the U.S. unemployment rate by May 2020. Over 20 million people were suddenly out of work due to widespread shutdowns. It was the highest unemployment rate the country had seen since the Great Depression. An infectious disease instantly paralyzed the global economy. No warning, just a complete halt.
The initial human cost was equally immense. By that same month, May 2020, the U.S. had recorded over 100,000 deaths. We saw dire shortages of personal protective equipment, PPE, forcing healthcare workers to reuse basic supplies. And the data quickly revealed some really stark realities. Early CDC reporting showed glaring disparities. For instance, in Chicago, Black residents initially accounted for 68% of COVID-19-related deaths, even though they made up just 30% of the population. At the exact same time, the Navajo Nation faced the highest per capita infection rate in the U.S., which prompted these incredibly resilient grassroots public health campaigns within those communities.
Section 2. The global response. Science and lockdowns.
So how did the world fight back? Well, the global coordination required was astronomical. We saw the deployment of unprecedented public health and social measures, or PHSMs, which included global lockdowns and total border closures. Concurrently, governments poured billions of dollars into initiatives like Operation Warp Speed. This funded the concurrent development and clinical trials of novel mRNA vaccines, effectively condensing a decade of scientific development into mere months. It was a real game changer.
It's wild to look back at the stark contrast in global strategies over time. Early 2020 brought paralyzing strictness, right? Stay-at-home orders, universal mask mandates, border closures. But as we move forward in the timeline, we see this gradual reopening phase driven by vaccine rollouts and a shift toward conditional guidance. The whole approach evolved from trying to completely stop the virus to managing it. This really eased the immense burden on society and the economy as medical countermeasures finally became available.
And speaking of those medical countermeasures, 10,704,043,684. That is the total number of COVID-19 vaccine doses administered worldwide by March 2022. It represents an absolutely unparalleled scientific and logistical triumph. Over half the globe was fully vaccinated in record time, which fundamentally altered the trajectory of the pandemic.
Section 3. The current reality in 2026. A stabilized world.
Now, what's really interesting about this assessment is the striking paradox it presents. The official World Health Organization assessment for 2026 classifies the overall global risk of COVID-19 as moderate. But, and this is a big but, their confidence in the available information is low. So we've stabilized the severity, but our visibility into the virus's ongoing behavior has severely diminished. The direct impact right now is moderate, mostly thanks to massive population immunity. We're talking about a 90% global seroprevalence from past infections and those historic vaccination campaigns we just talked about. But current vaccine booster uptake, even among highly vulnerable groups, is alarmingly low.
We're essentially relying heavily on past immunity while the virus just continues to circulate around us. So the crucial takeaway here is this. We have massive surveillance gaps. Because testing has decreased so much, genomic sequencing and global reporting have absolutely plummeted. This is especially true in low and middle income countries. We're scaling back our genetic tracking, which leaves us partially blind to how the SARS-CoV-2 virus is mutating today. Yes, we're enjoying stability, but we are doing it with our eyes half closed.
Section 4. Lasting Health and Society Impacts. The Long Shadow. According to the WHO, an estimated 6% of symptomatic COVID-19 cases progress to post-COVID-19 condition, which is widely known as long COVID. Now, 6% might sound small, but when you consider the hundreds of millions of global infections, that slice translates to millions upon millions of people still dealing with debilitating long-term symptoms. We're talking profound fatigue and cognitive dysfunction lasting months or even years after their initial infection. Researchers believe 3 core mechanisms are driving long COVID. Step 1 is viral persistence, meaning parts of the coronavirus remain hidden in the body, causing direct cellular harm. Step 2 is a dysregulated immune response, where the body's defenses essentially get stuck in overdrive, causing prolonged inflammation. And Step 3 is altered clotting, leading to microscopic blood clots that restrict oxygen flow to organs and tissues. It makes the complex biology of this lingering illness deeply fascinating, though obviously devastating for those experiencing it. But this long shadow isn't just medical, it's environmental. That rapid shift we all made to remote work and online learning dramatically increased sedentary behavior and screen time. Urban planners are actively analyzing this data right now, realizing that city designs absolutely must prioritize robust access to urban green spaces and outdoor areas. It's a critical public health need to combat the mental and physical tolls of a more isolated, indoor-centric society. Section 5. Preparing for the Next Threat, the 100 Days Mission. Looking at the 2026 RVMC report, the Coronavirus family remains right at the top of viral families with high pandemic potential. Science tells us that coronaviruses, with their ability to jump from animal reservoirs to humans, that process known as zoonotic spillover, remain a prime, highly prioritized suspect for future global outbreaks. We absolutely cannot just cross coronaviruses off the list. They are very much still an active threat. And sadly, they aren't the only threat out there. In 2025 alone, Mpox spread to over 40 countries. We saw H5N1 avian influenza spilling over into U.S. dairy cattle with sporadic human cases. We witnessed dangerous resurgences of Marburg virus, Ebola, and even measles. These recent data points prove that our global response systems are currently being pressured, and frankly, they're too fragile to handle the growing volume of complex infectious threats emerging all at the same time. So what's the solution here? Enter the 100 Days Mission. This is an incredibly ambitious global initiative. The goal is to develop and deploy diagnostics, therapeutics, and vaccines, what experts call DTVs, within exactly 100 days of identifying a new pandemic threat. Rapid, coordinated action is absolutely our best defense against the escalating pace of emerging pathogens. It aims to make the miracle of Operation Warp Speed the baseline standard, rather than just a one-off exception. But here is the most profound and sobering takeaway from the latest global reports. The greatest concern isn't actually a single outbreak. It's the widening gap between what science can do and what our political and financial systems currently enable. Just think about that for a second. Our bottleneck is no longer just technology or laboratory science. Our vulnerability lies in human coordination, sustained investment, and political will. The gap between what science can do and what our systems enable is widening. We've seen how a single coronavirus can reshape the entire world in 5 years, and we've mapped out the ambitious goals needed to stop the next one. But I challenge you to really ask yourself, are we truly ready for the next 100 days? Thank you so much for joining me on this explainer. Keep learning, stay curious, and I'll catch you next time.